All right, we're going to look at section 4.5, graphs of tangent, cotangent, secant, and cosecant. We've already talked about how to graph sine and cosine, so we're going to talk about how to basically graph our remaining trig functions. So let's start off with tangent, and tangent x equals sine x over cosine x, which another way of putting that, the definition we've talked more about is that it equals our y value over our x value. Well, if our y value is what sine x is and our x value is what cosine x is, then hopefully it makes sense that we can say that tangent x equals sine over cosine. What this means as far as our graph for tangent is that where sine of x is 0, I will get a 0 on top of this fraction, which means that that's where tangent will be 0. And where cosine is 0, I will get a 0 on the bottom, which gives me undefined values. And so anywhere cosine was 0 when we graphed it, we will have vertical asymptotes. So we're going to go ahead and graph y equals tangent x. And so I'm going to start off by making tick marks, and I'm going to make every tick mark worth pi over 4. So my second tick mark would be pi over 2, my fourth one would be pi, and over here at 6, that'd be 3 pi over 2. And I'm making it this because I know what's coming, and then after we graph it, then you'll know as well. But if you're like, why did she pick those values? It's because I know what I'm doing, and then you'll know to make it like this as well after this. Okay, so let's look at our unit circle to help us. We're going to look at our y values over our x values, and we're only going to look at certain points. We're going to look at 0, so this point would be 0, and my y value over my x value will be 0 over 1, which is 0. So that would be we're saying at the angle 0 that my y value is 0. I'm going to go over to pi over 4. So at pi over 4, I have the square root of 2 over the square root of 2 over 2. Since those are both the same, then that's 1. Up here at the top, this angle is pi over 2. If I put 1 over 0, I actually get something that's undefined. So I wouldn't have a point at all. I would say that at pi over 2 it's undefined. And I can just keep going around here labeling these points, like 3 pi over 4. If I have square root of 2 over negative square root of 2 over 2, that's negative 1. And then at pi, I'd have 0 over negative 1, which is 0. So with these points, I can get a pretty good idea of what my graph looks like. I start at 0, 0, and put a point. And then at pi over 4, which is my first tick mark, I'm at 1. At pi over 2, I have a vertical asymptote. Okay, at 3 pi over 4, I'm at negative 1. At pi, I'm at 0. And actually, I guess we need to go a little bit farther here. 5 pi over 4 would be a negative square root of 2 over negative square root of 2, which would be a positive 1. So that'd be right here. And then 3 pi over 2, I'd have that undefined situation again, because negative 1 divided by 0, I can't actually do. It's undefined. Okay, so if I think about like what's going on, I have two asymptotes here. And so if I start at 0, my line is going to curve up and get closer and closer to that vertical asymptote. And then going the other direction, it's going to curve down and get closer and closer to that asymptote. Okay, and so basically what I can take from this is my asymptotes are pi apart, because from pi over 2 to 3 pi over 2 is pi. So every time I go in this graph, 4 tick marks, I need a vertical asymptote. So like I need a vertical asymptote right here. And I need a vertical asymptote right here. Okay, and then between my asymptotes, the very middle point is at 0. To the right, I'm going up. To the left, I'm going down. And then I can draw that curve going up. And then the curve going down. Okay, and then so this one, I have a point in the middle, and then it's going up and to the right. And down and to the left. Okay, so some things we need to know about tangent x. Well, we don't really have an amplitude. That's not something we talk about with tangent and cotangent and cosecant and secant. There is no amplitude. If I have a number in front of tangent, like if I had an A for my tangent x, then that A is talking about my vertical stretch, just like it did with sine and cosine, but we don't really call that an amplitude in this case. We also can talk about if I had a B in front of x, tangent of bx, the B is still talking about my period, or it's helping me find my period. But normally, like a normal tangent graph has a period of pi, okay, because we completed this one tangent graph from asymptote to asymptote by going pi. Okay, so we compute our period by saying pi over b. So for sine and cosine, it's 2 pi over b because the normal period is 2 pi. But for tangent and cotangent, it'll be pi over b. And so basically the main points on this that we want to talk about, like the things that are important, are where are my asymptotes. If they wanted us to like say what the domain of this is and basically tell where all of my vertical asymptotes would be, well, I have an infinite number of them, right? Because my graph keeps going. But what I can say is that my vertical asymptotes are at pi over 2, because if I look, I have a vertical asymptote at pi over 2. And then what do I have to go to get my next vertical asymptote? I have to go pi, so I can say plus pi times n. And so what I'm doing is I'm saying what all of my vertical asymptotes are, because I can find any vertical asymptote that's on this graph by plugging in whatever number for n that I want to. And we can plug in negative numbers so that we're actually subtracting and getting, you know, negatives over here. We can put in regular numbers and get positives, so we're talking about over here. Another thing we can do is we can talk about our zeros of this graph. Well, my first zero started at 0. Okay, and then my zeros are also pi apart, and so we'd have 0 plus pi n, which we can also just write that as pi n. Okay, we don't really need the 0 there. Okay, so that's some things we can talk about with tangent. We can also shift up and down, we can shift left and right, just like what we did with sine and cosine. Let's look at cotangent. And so cotangent is cosine over sine, which is the same as saying x over y. And so let's think about, basically we're flipping the values from the previous problem. So this is 0, comma, oh wait, 1 over 0 is undefined. So that's going to be an asymptote. This would be still pi over 4, comma 1. This one, instead of being undefined, will be 0, so pi over 2, comma 0. This one will be 3 pi over 4, comma negative 1, just like on the last one. But this one is undefined because negative 1 over 0 is not defined, so undefined. And we can just keep going around like what we did on the last one. And so basically it's the flipped version. Like we're having our points flipped of what we did before. Now that doesn't mean that all I'm doing is flipping my graph. It's close to that, but it's kind of interesting that not just a flip happens here. Let me finish labeling. So hopefully now we can understand why I labeled the way I did. That we know we want pi as our period for tangent, and cotangent's the same way. Our normal cotangent has a period of pi. So it's great to have pi be, you know, something here that's 4 out, because that's really going to work for this graph, because that's the period. All right, so at 0, I'm undefined. So I have a vertical asymptote here. At pi over 4, I'm at 1. At pi over 2, I'm at 0. At 3 pi over 4, I'm at negative 1. And then at pi, I have another vertical asymptote. So see what happened? Not only did we flip our graph upside down, basically, because look, I'm going down to the right, and I'm going up to the left. Okay, but also I shifted it over. On the previous problem, our asymptotes were at negative pi over 2 and pi over 2. On cotangent, they're normally, if we don't have any shifts or stretches or shrinks or anything, at 0 and at pi. Okay, so they're still pi apart because that's the period, but it's shifted over from where tangent is, and it's going down to the right and up to the left, which is the opposite of what it was on tangent. Looks like I made a mistake here that wasn't supposed to really be pi. That's negative pi.
Not going to do jazz band at this time. We're going to do that on a separate day, separate time. So DECA, BPA, Managers and Traders, and Key Club.
Okay, and we just basically are finishing our graph. And you don't necessarily have to do the things I did on the end. I think that makes it look fun because it makes it look like I'm a calculator, and so I actually did everything that was in my viewing window. But like if it asked us for 2 periods of cotangent, we would just need this right here in between these two asymptotes, this right here in between these two asymptotes. So for this graph, again, we don't have an amplitude. If there's a number in front of cotangent, then that's a vertical stretch or vertical vertical shrink. If we have a number in front of x, that affects the period. Our normal period for cotangent is pi. Okay, and so then to find the period of the graph, we do pi over b if there is a b in front of x. And then if we want to do our vertical asymptotes for this graph, then it starts at 0. That's where one of my vertical asymptotes is. And then I have a vertical asymptote every pi after that. So we could say x equals 0 plus pi n, or just x equals pi n. If we wanted to talk about where our zeros are, they are at pi over 2. Okay, and then I would add pi in, and because I have a 0 at pi over 2, and then every pi in after that. So that's cotangent. Secant is 1 over cosine, and so that's also the same thing basically as saying that it's 1 over x. And so what we want to do when we graph this, the easiest way is to actually go ahead and graph cosine x so that we can then flip our values and get secant. So I'm going to set up a graph for cosine here. So the period of cosine without anything changing it is 2 pi. Okay, I don't have anything in front of x. Okay, and so I'm going to write it as a dotted line because the graph of cosine is not actually like my answer to this. The graph of secant is. Okay, but I do want you to draw both. So cosine starts up here at 1, and then by my first tick mark needs to be at 0. By the next tick mark needs to be at the bottom. Basically halfway I need to be down at my bottom amplitude. Then I go back up, and at 2 pi I need to be back where I started. So I'm going to make this a dotted line for cosine. I think I got a little off there then, maybe. No. Okay. So let's think about some of our values here. Like whenever cosine is 0, okay, if it's 1 over cosine that I'm really graphing, where cosine is 0, I have 1 divided by 0, which is a vertical asymptote. So every place that my graph goes through 0, I'm going to put a vertical asymptote. Like so. Every time it goes through 0, I need a vertical asymptote. Which it kind of goes through it a lot, so da-da-da. Okay, now another point that I can look at is basically the top and bottom values. This right here is 1. If I flip 1, I still get 1. Okay, so and that's going to be true on all of these points, that is actually a point on our secant graph. Now from there, if I'm flipping, like if I flip this part right here, wouldn't it actually be something that looks like this? Kind of like a parabola going up. And if I flip this right here, then that's like a parabola that's going down. So each of these, that's what's happening. Okay, that we kind of do the opposite direction of what it is for our cosine graph because we're flipping it. Okay, but since where cosine is 0 is an asymptote, like my graph keeps going and just keeps getting closer and closer to that asymptote as we get closer and closer to where that value for cosine is 0. So the best strategy on any secant, whether it's shifted, stretched, whatever, is change it to cosine and graph that as a dotted line, and then do what we just did, where you put vertical asymptotes where the cosine graph hits 0, and then you draw your basically your u's and your n's on the graph. So the normal period of secant is 2 pi. We basically just work with what we did with sine and cosine. One thing we might have to do is say where our vertical asymptotes are on this graph, and so we would pick one, like there's a vertical asymptote right here, which is pi over 2. And then I would have to say, okay, how far apart are my vertical asymptotes? And it's not that they're what the period is, because there's actually 2 vertical asymptotes for each period, or 3, depending on how you want to look at it, maybe. But okay, so there's 2 of them right here, so that's pi apart. So pi over 2 plus pi n. Okay, we can't talk about zeros on this graph because it doesn't, our graph, which is in green, does not go through the x-axis. But we could talk about our maxes and our mins, our local maxes and mins, which this right here, okay, this right here is a max, okay, because look, it's basically the top of a hill. Okay, well, where is that point? That point is at pi. Okay, and let's say that I wanted to make this into a point. I have a max at pi, comma, -1. But if I wanted to say what all of my maxes are, well, let's think about how far apart are our maxes. Like, how far apart is this max and this max? That should be 2 pi because that's our period. So pi plus 2 pi n, comma, -1 is where all of our maximums are for this graph. Our minimums would be, let's pick a minimum like this one right here, are at 0, it's at 0, 1, so that'd be like 0 plus 2 pi n, because all of our mins are 2 pi apart, and this time it's 1. And you see all of our maxes, all of our maximums will be at -1, and all of our minimums will be at +1. Okay, so that's what we can do for the graph of secant. Cosecant is going to be related to sine, okay, because it's 1 over sine. So we're going to start off by graphing the graph of sine x as a dotted line. So sine starts at 0, starts in our middle, and starts at our middle. Then if it's positive, it goes up first to our amplitude, and then it goes back to 0, goes down to our bottom amplitude, then comes back up to 0. So it's gonna look like this. And then I can do it the other way. Okay, so now we want to do basically what we did with secant, where every place that it goes through 0 is a vertical asymptote. Which again, there's kind of a lot. And then once we're done with that, we're going to make our U-shapes, and we're going to make our ends. That's what they look like. And yes, I want you to do everything that I am doing on my graph. Like, I want you to show me what the graph of sine is, and then I want you to draw the vertical asymptotes, and then I want you to draw, preferably a little bit darker, or, something that makes it more obvious than the rest of the graph, something to show that you actually know. Oh, look, I forgot this one. That you actually know what the graph of cosecant is that it's these u's and n's. So as long as we can graph cosine, we can graph as long as we can graph sine, we can graph cosecant. Okay, so let's talk about what we can know about this. Our vertical asymptotes would be at, well, it starts at 0, that there's 1, and then it happens every pi after that. Okay, so we could say 0 plus pi n, or we could just say pi n. Our maximums happen at, well, one of them is at between pi and 2 pi over 2, which is 3 pi over 2. So we can say it's the point 3 pi over 2 comma negative 1. Well, we could say that that's one of them, but let's say what it is, what all of them are. So that's 3 pi over 2 plus our period, which is 2 pi n comma negative 1. And then our minimum is, let's see, there's a minimum at pi over 2 plus 2 pi n comma positive 1. Okay, so that would be how we would graph cosecant. So just kind of to sum up a little bit on this, we have the same transformation rules with these functions as we do all of the other functions, that we can vertically stretch them, we can vertically shrink them, we can reflect them across the x or the y axis, we can have shifts up and down, shifts left and right. But the thing that's different from sine and cosine is we don't use the term amplitude, and we don't use the term phase shift like we did with sine and cosine. So they'll tell you horizontal shift, but they won't say phase shift for these. Okay, so that is all that I have for you here.